So we're going to look at solving word problems algebraically, and today we're looking at number problems. So the whole idea is that I know you guys have other means to solve, such as using guess and check, which is often a favorite method for students to use. However, there are some limitations, of course, to guess and check. So in some cases you might guess the answer right away. In other cases, it could take you a really long time to actually figure out what the exact value is. Other times people choose to use logic. And again, some of us are more logical than others. Some situations lend themselves better to solving logically than others. So these are two methods, guess and check and logic are two methods that you already kind of have in your back pocket as a means for solving, for problem solving. So what we want to do is to explore an additional method, which is solving algebraically. So I know that there are questions here that you guys are probably able to do logically or guess and check. We know that we've got those methods. Right now, our goal is to practice how to do them algebraically, because as problems get more difficult, we want to have these methods, this little tool in our toolkit to be able to use as things become more complex. Okay, so in general, for solving word problems algebraically, we're going to follow pretty much the same steps. So the first one for solving all word problems, of course, is to read the question carefully. Okay, so of course you're paying attention to any key terms. You're perhaps looking at drawing a diagram, but it's just understanding what details are given to you. You might even make a little note as to what information you already know, and obviously you're paying attention to what it is that you want to find. So once you've read it carefully, then we are going to label the variable. So you decide which of your 26 letters you're going to use from the alphabet. Pick a letter, and you want to be specific about what it represents. Use units as well if applicable. So rather than just saying, hey, I'm going to have n equal, n is going to be the number of, or n is nickels. Be specific. Are you talking about the number of the nickels? Are you talking about the value of the nickels? Are you talking about the weight of the nickels, the diameter of the nickels? So be very specific and use units where needed as well. The other thing about labeling the variable is sometimes what we're actually trying to find isn't always, like in terms of answering the question, isn't always what we're solving for. So it's important to label the variable. The better job you do with labeling the variable, the easier it is to write your equation. And the equation, creating that equation is going to be the toughest piece of this whole process. So that is part 3 then, is to write the equation. Okay, so the equation essentially should tell a little story. If you've labeled your variable really clearly, then your equation actually tells a story, and all of the units where applicable match up as well. Once we've written our equation, I know we've gotten really good at solving, so we're going to solve the equation. And then the next piece is that we're going to find the other unknowns. Okay, so in some cases you're being asked to say find 2 numbers or find 3 numbers. So you've only solved for one of them. You need to find the other unknowns that may have come into play in the question. Okay, then we're going to do our check, but different from a checking of our equation, we're going to check ideally using the context of the question. And the reason why we're going to use the context of the question is because we are the ones who created the equation. And so if we made an error with the equation, then it doesn't necessarily answer the question itself. So it's important to check using the context of the question. And then finally, once we know everything is clear, we're going to write a brief statement that answers the question. Okay, because again, what we solve for doesn't always answer the question. So just because you finish off and you say x equals 7, well, if you were actually asked what is the value of the nickels and you solve for the number of nickels, then 7 is not actually answering the question. Okay, so let's take a look then specifically at some number problems. Okay, so the question is, find 3 consecutive odd integers that have a sum of negative 117. So in reading the questions, I'm recognizing a few key things. So we're looking for 3 integers. They are not only consecutive, but they are odd integers. And the sum is negative 117, meaning they add up to negative 117. So I need to label, except there's 3 unknowns, so I can only use one variable. That's the only kind of equation that I actually know how to solve, is an equation with one variable. So we have to decide which number the variable is going to stand for. So if you're unsure of how to do that, so again, something that you can do is say, hey, what's an example of 3 odd integers? Okay, well, we could have, for example, 3, 5, and 7. So let's say we decided to let our variable be the first integer. If x was 3, then how do I get to my next integer? Is I would need to add 2 to x. So that would be x plus 2. And then, of course, it makes sense that the third consecutive odd integer is going to be 4 more than the original, or 2 more than the second. So x plus 4 then. Alternatively, if you had your variable, let's call it a, if we decided that your variable was the second integer, well then the first integer is going to be 2 less than the second one, so it could be a minus 2, and then the third integer is 2 more than a, so then a plus 2. And then, of course, you could see that I could also label my variable n as being the third integer. And so if n was 7, well, then the second integer is 2 less, so n minus 2. And the first integer is 4 less than the original, or 2 less than the second one, so then n minus 4. So what I'm trying to demonstrate here is the fact that your variable could actually represent any of those 3 integers, so it is important for you to be clear in your labeling. So let's say then that we decide that we're going to label the variable as the first integer then. So we can say then that x is the first integer. Then that would mean that x plus 2 is the second integer, and x plus 4 is the third integer. And again, at the end of the day, you could just tell me what x is and leave out the x plus 2 and x plus 4, but if you're having troubles writing your equation, then labeling for all of the unknowns definitely helps to make it a lot more clear for us. So now that we have our labeling done, we can write our equation. And so because we've been very clear about what our 3 integers are, we now see that they have a sum of negative 117. So here we have it, the first integer plus the second integer plus the third integer has a sum of negative 117. And so it's very, very clear based on our labeling what the question actually was to begin with. And then we can go ahead and solve. So combining our like terms on the left side, we've got 3x plus 6 equals negative 117, and then we'll subtract 6 from each side, so then 3x is equal to negative 123, and then divide both sides by 3, and x is equal to negative 41. So then, now that we've solved the equation, remember, going back into those steps, the next step we want to do is to find those other unknowns. And so that's where it helps to go back to your labeling. Oh yeah, x was my first integer. In order to find my second integer, I needed to add 2 to that. So it's negative 41 plus 2, or negative 39. And then the third integer is then x plus 4, or negative 41 plus 4, which is negative 37. And so it's good to have that labeling as well, because I could imagine that some people might take negative 41 and just say, oh, okay, well, odd integers, negative 41, negative 43, and negative 45, which of course would be incorrect. So we've found our other unknowns. We think we know what our 3 numbers, consecutive odd integers, are. So our check is simply in the context. So I'm not doing a formal left side, right side check. I want to say to myself, okay, in the context, do I have 3 consecutive odd integers? Negative 41, negative 39, negative 37. Yes, that's true. Now, is the sum negative 117? Well, let's see. If I add them, then I could just go ahead and stack them up, or if I have my calculator, I can put that into my calculator. So that is 17, carry the 1, that's 11, and because we're adding all negatives, then it is negative 117. So that checks out, and so then we need to write a brief statement answering the question. And so we can just say the numbers are negative 37, negative 39, and negative 41. So simple as that. If you wanted to, you could also be that much more specific and say the 3 consecutive odd integers are negative 37, 30, negative 39, and negative 41. And that just gives us an extra little check as well. The biggest mistake that students usually make with this is, rather than labeling for consecutive odd integers, they label for just consecutive integers. And by writing out that final statement, it helps to catch us. Obviously, if you also ended up with something that was a decimal or a fraction, that also doesn't answer the question, and you will know that you've made an error. Okay, so let's take a look at the next question then. Okay, so for this question, find 3 consecutive integers. So the sum of double the smallest integer and triple the largest integer is 66. So again, if we look at consecutive integers, if we say, let's make n is the smallest integer, and n plus 1, because we're talking about consecutive integers such as 3, 4, 5. So the next consecutive integer is just 1 more than the first. So n plus 1 is the second integer. And then n plus 2 is then the largest integer, or the third integer. So what do we know is we're just going to write out exactly what it says. So the sum of double the smallest, so I want to double the smallest, so 2 times the smallest, and we're finding the sum of triple the largest. So if I just write 3n plus 2 and then equals 66, we've actually got a pretty critical error right here, because what are we tripling is we're only tripling the smallest integer. If I want to triple the largest integer is actually all of n plus 2. So if it helps you, some students might find it helpful to put some brackets, parentheses around something that has multiple pieces to it. A binomial is what we would call that. We'll get into that a little bit more later. So there we have it. And again, this is what I'm talking about when we have a story of an equation. You can look at your labeling almost serves as a legend. So 2n, 2 times the smallest, 2 small integers plus 3 large integers is equal to 66. So the equation fully makes sense then. So go ahead and solve, and then you just even hit pause and then come back and check with my solution then. Okay, so we're going to distribute that 3 in. So 3 groups of n plus 2 means we have 3n plus 6 is equal to 66. We'll combine our like terms on that left side. So 2n's and 3n's make 5n's plus 6 is 66. Subtract 6 from each side. So 5n is equal to 60, and then we'll divide both sides by 5, and n is then equal to 12. So we've solved our equation, and now we want to find our other unknowns. So n plus 1 is our second integer, which is 13, and n plus 2, or 12 plus 2, is then 14. Our check in context then is, do we have 3 consecutive integers, 12, 13, 14? Yes. The sum of double the smallest, so 2 times 12, that gives me 24, and triple the largest, so 3 times 14 is 42, and then we add them together, and we do in fact get 66. So that is our check in context. And so does that kind of look like our original equation? Absolutely, and it probably will, but at the end of the day, we want to use the context, because the equation was something we came up with, and we're not guaranteed that it's correct. So then our final step is to answer the question. So it's finding 3 consecutive integers. So we can say then the 3 numbers, or the numbers, are 12, 13, and 14. Okay, awesome. Please let me know if you have any questions. Thank you.